Hello guys. Now in this video we are going to see inequalities. Yes, you already know about these inequalities in functions as well. But we cannot say inequalities are totally in functions. Functions is totally about inequalities. Inequalities do mean which are not equal, like less than, greater than, less than, greater than equal to, less than equal to. These are the signs that we use to represent inequalities. That means if you say x is equal to 2, this is only one unit. Okay, it is defined. But what if I say x greater than 2? It has many solutions that are possible for given limitation. Okay, like that. Excuse me. In the same way, our inequalities are having about these limitations only. So we have to define the limitations of each expression. Yes, we already solved these things in functions. That is about when we are finding domain, range, and all these things. But in particularly inequalities, I want to discuss about a wavy curve method, which is very useful method for finding the ranges or domains very easily. So when we compare only inequalities, when I compare inequalities with the functions, inequalities do constrain. It is only small set. Okay, in functions it is only small set, but in functions it's wider than inequalities. That means it defines inverse functions, okay, for complex functions, combination of different functions as well also. Okay, inequalities is part of that. So in these inequalities we are going to know the wavy curve method. In this wavy curve method, whenever your expression is in this form, okay, in this form, you have to find critical points. Okay, what if my equation is not in this method or in this way, which is not very which is not that complex? What if it is very complex, like x square plus 3x plus 4? You have to convert into this. What is this form? This is the factorized form of an equation. Factorized form. So when I convert a quadratic equation or a polynomial in terms of a factorized form, then I have to find critical points. What are critical points? Critical points are those where this polynomial or a given equation is having a different turn or a different slope, like that. But let's not discuss about the slopes and all these things in this method, in this chapter. So in a number line, this shows at x equal to 2, this curve makes this value 0. Okay, that means at x equal to 2 it has a critical point. In the same way, you have to equate every factor to 0, then x equal to minus 3, this is x equal to minus 4. Okay, so these are the critical points that we have to consider before going into solving finding the inequality. So in this, so x equal to, let's draw the number line again, it's 2 minus 3 minus 4. Okay, now what we have to do? What is the extreme, rightmost extreme point here? It's x equal to 2. That means this value, this factor. That factor gives us this critical point. Now we have to mark this area as positive. Remember that. Okay, we have to take rightmost critical point, right side of the rightmost critical point as positive. Now let's go to the factor. Which factor is giving my critical point 2? Which is x minus 2. See its exponent. What is this exponent? What is the exponent of this factor? It's 1. If 1 is an odd number, yes, obviously it's an odd number. If my exponent is an odd number, I have to change my sign here. If this is showing plus sign, it has to change as minus here. Okay, what if that is an even number, even exponent? It should not change. This plus will continue here also. Why I'm writing plus and minus, you will understand it. Okay, so plus minus. Next, x plus 3. Which one is giving this critical point? X plus 3. What is its exponent? It's even. Yes, now I should not change it. I have to continue with this, which is minus again. Now x equal to minus 4. One exponent is odd. I should change my sign here. So I'm going to plus sign. Now what they are asking? They are asking about less than 2. That means if I take minus 2 here, it will be less than 0. So they are asking where this whole polynomial or given equation is less than 0. That means negative. So these are the areas where my points are negative. Okay, so these critical points also has to be neglected because they make the whole curve as 0. If I take x equal to minus 3, so this whole thing will become 0, isn't it? Sorry, it takes minus 2 here. 2 is there, so it takes minus 2. If this 2 is not there, then whole thing becomes 0. So when this 2 is there, this whole thing will be negative only. So these are the things. X less than minus 4, my limits are x less than minus 4 and sorry, x is greater than minus 4, right? This area, and x less than 2. These are the things. But observe carefully. They are asking strictly negative. Strictly negative means it's not equal to. Okay, that means I should, when I represent in terms of a bracket, I should use open bracket. Why? Because it's strictly less than 2. That means it should not be equating to, or it should not include 2. That means I have to take an open bracket here, minus 4 comma 2. I hope in the previous video we have discussed about these brackets. So minus 4 comma 2 is the solution for this. Okay, now let's go to one of the previous year problem. Yeah, so if x belongs to a comma b satisfies the inequality x minus 3 by x square plus 3x plus 2 greater than or equal to 1, then the largest possible value of b minus a is. Yeah, you can do this or you can solve this in many ways, but one of the way is sorry, x minus 3 divided by x square plus 3x plus 2 greater than or equal to 1. Okay, fine. Let's solve this one first. Take minus 1 here. It will become x minus 3 minus x square minus 3x minus 2 and x square plus 3x plus 2. So this becomes minus 4x, sorry, not minus 3x, and minus 5 okay, sorry, minus 2x. Okay, so remember this. So this is all minus. If you have to remove this minus, I have to multiply on both sides with on both. This is 0, right? I have taken 1 here, so this is 0. So I have to take multiply with minus. Then the symbol changes. The symbol will be opposite here. X square plus 2x plus 5 x square plus 3x plus 2 less than equal to 0. Okay, so now the first the numerator can be written as x plus 1 whole square plus 4 divided by, this can be factorized as x plus in what way we can use that, x square plus 2x plus x plus 2. That means x plus 1 into x plus 2, right, less than or equal to 0. This whole thing can be negative. Less than or equal to 0 means that only, right? This whole thing can be negative only when either this is negative or this is negative, right? but this cannot be negative. There is only one way, that this is negative. That means x plus 1 into x plus 2 has to be less than 0, or equal to 0. That means what are the limits? Critical points, minus 1, minus 2. Rightmost, this one would be positive, and minus 1, its power is an odd number, so this converts into minus, and minus 2, it will convert into positive. Now my question is about this one. So the answer lies in this. It is less than or equal to 0. That means it is not that strict. So minus 2 to minus 1, which are open. But this cannot be equal to 0. The denominator cannot be equal to 0. So I have to remove this equal to symbol also. It should be strictly less than 0. That means they should be open. So x belongs to minus 2 comma minus 1. So the values of a and b are minus 2 and minus 1. So what they are asking, the largest possible value of minus 1 or minus of minus 2, that is 2 minus 1. Answer is 1. Okay. So here it's not about this possible value, but the way you solve this one. Okay. Other thing, the other way of solving this is, you can also write this as x minus 3 and this as directly as x plus 1 into x plus 2, but power minus 1 greater than or equal to 1. So like this also you can do it. Okay. Either way the answer will be same. You can check it. But here it's all about finding the limitations and through wavy curve method. So if you use wavy curve method, the thing will be very easy for you. Okay. So this is it for inequalities. Next class we will deal with progressions. Thank you.